This will be part 2 on our section 4.8. We're going to look at an isosceles triangle postulate. It tells you that the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. So this is an isosceles triangle. This dashed segment is the bisector of the vertex angle. So this is your vertex angle up here, and it's obviously getting bisected because these two are the same. This same segment is the perpendicular bisector of the base. So that means these two segments are congruent, and these are both right angles. Now, if you really wanted to, and you should be making these marks also, if that's an isosceles triangle, then these are the base angles of the isosceles triangle. So what happens is, in every single isosceles triangle, if you draw this segment on here, you can end up with two triangles that are congruent to each other. And they're congruent by side, side, side. Or you could have said they're congruent by side, side. Or angle, side, angle. Or angle, angle, side. Or HL. All of those methods you could use to prove that these triangles are congruent because you have all 6 pairs of corresponding parts congruent. Okay, so there's a corollary to this base angles theorem, and it tells you if a triangle is equilateral, meaning if all the sides are congruent, then all of the angles are congruent too. And then there's a corollary to the converse of the base angles theorem. So if a triangle is equiangular, meaning if all the angles are congruent, then you know that all the sides are congruent too. Here's an example. Notice how there's 3 triangles in this particular problem. Here is a triangle that is equilateral. Well, actually, it's equiangular, which makes it equilateral. So if all these angles are the same, we know they're all 60. And if all the angles are the same, then we know all the sides are the same too. So if this has a length of 4, this has a length of 4. So y is 4. We know that this side has a length of 4. This triangle down here, it's isosceles. These are the base angles, so these are the legs. If this is 4, then this is 4. Something plus 1 gives you 4. 3. Here's a problem on a lifeguard tower where we have some triangles that overlap, and they actually make another triangle here. In the lifeguard tower, segment PS is congruent to segment QR. So we know this, and angle QPS, that would be this angle, is congruent to angle PQR. That would be this angle. What congruence postulate can you use to prove that triangle QPS is congruent to triangle PQR? Well, hopefully you recognize that this segment PQ is on both of these triangles. It lives right here by the reflexive property. So you could use the reflexive property to say that those are congruent, and then you could use side angle side to say that these triangles are congruent. Explain why triangle PQT is isosceles. Well, here's triangle PQT right here. It's actually a triangle formed by these two overlapping. Well, if these triangles are congruent, doesn't it also mean that angle 2 is congruent to angle 1? That's CPCTC. So CPCTC tells you that those angles are congruent to each other. And then if you just look at that triangle PQT, you can definitely see it's isosceles because angle P and angle Q are congruent. So CPCTC gives you congruent base angles. Show that triangle PTS, that's this one, is congruent to triangle QTR. That's that one. And I don't have these drawn, so this might be a little bit tougher to see. But we definitely have vertical angles here. I can mark that. Also, if these two triangles are congruent, which we know they are, I'm going to have to use 4 arcs, but angle 3 and angle 4, they're congruent by CPCTC. You can see why drawing a separate picture is really a good idea because this gets really, really busy, really, really fast. And then segment PS, we already have one slash mark on it, and segment QR, we have one congruent slash mark on it. If you focus on these two little triangles that they ask you about, they're congruent by angle, angle, side. So there's a lot of triangles here. There's two big ones, there's that little one there, and then two little ones on the sides there. All of these triangles are related. If you can show that two of them are congruent, you can show that a lot of the other pairs of triangles there are congruent too. Here's an example. Find X and Y. So this big shape is not a triangle. Be careful there. But there is an equilateral triangle here, which behaves just like an isosceles triangle. But if all of the sides are congruent, we know all the angles are congruent too. So we can make all of these angles 60. Notice how this angle is 90, which makes this guy 30. And this little triangle over here is isosceles. That's a leg, so this is your base. So if that base angle is 30, this base angle is 30. If your base angles are 30, that's 60 degrees. How many degrees is left for your vertex angle? 120.